don't sell it too hard.
And you brought another OCaml guru with you?
Yeah, Brian Hertz, the guy I had over here in the corner, he's my ringer. He programs OCaml full time. He's the guy who introduced me to it. I didn't actually expect him to be here, but it just so happened it worked out, so go for it. All right, I'm Robert Fisher, like you said. Most of you probably know that I'm obsessed with this programming language called OCaml. Some of you might not. I do some open source development in OCaml, including working on the libcurl port to OCaml, which is called OCurl. Bridge, not port. I'm also employed right now converting CoCan Wiki, which is an OCaml-based wiki, into CoCan CMS, which will be an OCaml-based CMS. But that project just ran out of funding, so I'm not so much doing that after this month. Anyway, the question here is, I'm coming up in front of Ruby.MN, I'm going to talk OCaml. Obviously, I'm going to sell you on why you guys want to learn OCaml, and I've got one simple answer. It's going to screw with you. It's going to warp your brain and make you think differently, and that's the kind of stuff that Ruby.MN likes to do. Ruby.MN, people here, they like to learn about new things, weird Moby apps, they like to learn about all kinds of different stuff, from compilers all the way up to the CSS and the browsers that display the web applications. OCaml, you go, you learn it, it will guarantee change the way that you write code. After I learned OCaml, I went back to writing Java and wrote Java that looked totally different. I'd encourage you to go check out my blog to figure out how, or talk to my coworkers who still kind of curse my name a little bit. OCaml is a statically typed language. This is going to evoke that reaction. But OCaml is an implied statically typed language, which means it should be evoking that kind of reaction. So OCaml is an implied statically typed language. This means that you declare variables. They are statically typed. The compiler checks them, makes sure that they look great, but you don't have to repeat yourself. Here's an example. Let xyz equal 2 false and hello world. I'm declaring 3 variables, or as I prefer to call them, named constants. X, which is an integer of 2, y, which is a bool of false, z, which is a string of hello world. This gives you a lot more static typing advantages without the pain that we're used to dealing with coming out of the Java world. And we'll see lots of examples of that as this presentation goes on. Your static typing. Your static typing will guarantee that your return types are what you expect them to be. You will no longer bump into an object when you thought you were getting back an int. And if you have 60 if statements all lined up in a row, every last one of them will return and will return the proper value. That's one of the things static typing gives you. Static typing will derive what your arguments are. Implied static typing, in this case, will derive what your arguments are and make them as generic as it possibly can. And we'll see a good example of this in the future. But basically, this means that you will, as you write your code, the compiler will sit there and tell you, oh, you thought that this was just useful in your particular case. The reality is, you can take that and use that in any place which meets a certain set of criteria, which is much more vague than what you originally expected. Of course, it also catches your typos and your API changes. So, like if you're me and you run into a case where you can't pass the object in anymore because your ORM is going to freak out at you if you do. And so then you have to start passing around IDs. You change from being an object to being an ID by treating the thing that you're dealing with as an ID, not as an object. And the compiler will tell you all the places where you need to fix your code because you just broke your API, as opposed to having to run your unit tests and hope you didn't mock them out to the point where you're now not catching this bug. It also is the core capability that powers the most advanced features in the language and the way in which it kind of warps your head. And you'll see this as we go on. Great, it's cut off at the top. In addition to being an implied statically typed language, OCaml is a functional language. It is a real functional language. I'm sorry, Ruby is great, it is not a real functional language. The reason why is because the key operation in a functional language is function application. Everything is a function application or a function declaration. Take your pick. There is no imperative do this, do this, do this, do this structure in functional languages. And because function application is the key operation, functions are the key type. So you think in terms of functions and in terms of types that go into functions. You don't think in terms of series of instructions, which is key behind the imperative structure that drives Ruby, Java, and basically every other language used in business. Here's a first introduction to a kind of mind-warping thought. This is going to suck for the people in back, and I'm sorry, but I'm going to, since function application is the most fundamental tool in OCaml, there's no syntax for it. The variable followed by the options does function application. So this x, y is applying y as the first argument to the function x. So if I say let f, I'm defining a function, I'm naming it f, of xy equal xy, what I'm saying is I've got a function which takes a function and applies an argument to that function. This is written out in OCamlese as a function which takes something and returns something. The something's being named tick A and tick B. That tick variable means something. And then it takes the something that matches that first type of your function, whatever your function takes as its first argument, and produces whatever the output is of that function. So you'll note there's some weirdness here in this variable definition. A lot of weirdness. But some of the weirdness is there's no clear delimiter between what's an argument and what's the return value. And that's intentional because you're going to write code like this. I'm defining a function g, which is taking f, and I'm applying the int of string function to it. Int of string takes a string, produces an int. So I've passed f, this int of string function in, as this x. This string, which is now my tick A, which becomes this. This int is now my tick B, which becomes this. Everyone's still following me?
Is it really that easy?
Yes. It is really this easy. This is called partial function application. When you do it just once on the leftmost argument or the first argument, it's called currying. Although people conflate those two all the time, so don't worry about it too much. It also gets kind of weird. In this case, I'm going to take this function with the weird name of plus. This would be integer addition. I'm going to pass that weird function with the name of plus, the argument 2. This now cuts me down to an int function, and put that into, apply that to f. That goes up there, we constrain these things, and that gives me my h. Of course, as a functional programmer, you'll realize, well, I'm just doing function application here, so I can just write it like this. Give me a variable k, this weird thing plus, set the first argument to 2, leave a second argument undefined, so that gives me an int function. This is just the start of what we're going through. We'll see some more here. So aside from functions, what can we deal with? Well, we've got simple data types, like your string, your ints, your floats, and your bools. And this weird thing called unit. And unit is, there's only one of them in the whole system. It's kind of like void, but don't think of it like null. We'll see more of unit later. We also have tuples. Tuples are basically a collection of a few things kind of lumped together. So in this case, I've got this variable called xyz, which is an integer, a boolean, and a string. In this particular case, 2, false, and hello world. Tuples will allow you to retain your type safety while lumping a couple things together. They're commonly used to return multiple values from a function, stuff like that. They're fixed defined size. You can't add things to the end. You can't pull things off the back. Some people call them endpulls, really geeky people with PhDs, because tuple, it technically refers to only the case where there's 2, and 3 would be a triple, and 4 would be a quadruple. And the unit thing that we talked about before is really the empty tuple, or the tuple that doesn't have anything inside of it, which is why there can only ever be one of them. You've got lists, which basically form the backbone of recursion in OCaml. Lists, unlike tuples, can only have a single type, which means that if you've got a list, you've got a list of a particular type, in this case string. And they can be arbitrary lengths, but they don't change length and they don't change content. That once you declare a list, the list is kind of set in stone. And the same is true with tuples. You've got records kicking around. Records are basically a way to organize data, which gives you this really nice field access notation. There's a couple other nice things about them, but really I'm not a huge fan. They do provide a nice way to hold on to mutable data. And this is one of the nice things about OCaml coming from a programming language like Java or Ruby, is in OCaml you've got mutable data, so if you need to fall back to that kind of mindset, you can. And the way that you're probably going to do that though isn't through records, but it's through references. References are the succinct, easy way to do data declaration. I told you before that I don't like calling them variables. I like calling them named constants because they are. Everything that you declare, once you say let this be that, it can't reassign it. In the case of a reference, you sidestep that by saying this is a pointer, basically. Not really. But this is a reference. And then, so I'm going to point to some spot off in some object I'm holding on to. So here's a case where I'm declaring a reference with the value of the integer of 2. We'll note two things. First, the type is safe on your references. So references, if they point to an int, will only ever point to ints. Second, they're really secretly records that contain a mutable entry in them. So references are basically just syntactic shorthand for a single element record. If you want to update the value of a reference, you use the colon equals operator. It is more expensive, or it is visually ugly and all that kind of stuff. That's good. You don't want to be doing mutable data anyways. And if you, after you assign it, that's what it's assigned to. Now this is the coolest part in OCaml that I've so far encountered. They're called variant types. Kind of like the enums that you're used to dealing with, but they don't have the suck, basically. And the best way we can start walking through them is to look at some examples. Enums are declared very straightforward. Here, I've got an enum, a variant type, so declared very straightforward. Here I've got a variant type. The type is called a hobbit, and it's one of two things, either this bear name Bilbo or this bear name Frodo. And then I can pass them into some kind of function, like the function hob, which takes a single hobbit, and I match the hobbit we passed in with either Bilbo, and then I return the string there and back again, or Frodo, and then I pass Big Book of Whining.
Is that like case types? Scala?
Probably.
Yeah.
I don't know Scala.
Okay.
The important thing is they don't just need to be constants, they can also hold values, and they don't have to hold the same value. So here's a rational type that I've declared, which is either an integer, just holding on to an int, or it's a frac, which holds two integers representing the numerator and the denominator. So now I can abstract out and talk about rationals in this more abstract sense, and then when it comes time to actually computing, I know that I'm going to handle one of those two cases. Let's look at a couple other examples. Here's a type IDX, which gives you a string index or a numerical index, take your pick. It can be used for data structures where you can be switch hitters. Here's a popular type called the option type. I told you before, unit wasn't exactly null. That's because none is null. This type is, again, something. So it's an option of something. And it's either something, or it's none. One of the two. Take your pick. The important part about using this is that the type system will actually force you to handle the none case. It will force you to handle it pretty quickly, in fact, which means that you don't get null pointer exceptions ever again. And this is something that I wish other languages would come to appreciate. Here's a maybe type, which gives you a result or an exception. Here's the definition of a list. One line, I now have a linked list. And the list consists of either an empty list, or it's a node of something and the same kind of list at the end. Shoot.
Just to clarify, declarations are by default non-nullable then?
Right, yes. There isn't, you can't have a nullable. What you'll have is, there are people who ask, well, how do I implement the pattern where I declare my variable at the top, and then I initialize it somewhere in the middle, and then I use it later on? The answer is you don't want to do it. But if you really need to do that, the way that you do it is you have a tick a option ref. So you have a reference to the option type, which holds something. And so then you work your way through it, and then you can assign none to it right off the bat. And then you can assign something
So the
else.
reference type can refer to none until they refer to something else? Or is that's basically how it works?
Yeah, that's how it works. It will refer to none until they set it to be something else.
Okay.
The same way where if they declare it at the top, it'll be null until you assign it to something else. But you don't want to do that because then you're turning a perfectly wonderful compile time check into a perfectly horrible runtime check. You have a question? Okay. So anyway, there's a linked list definition. Let's do it. Okay. What's next? I don't know. My clicker's not working. My clicker's freaking out at me because it's thinking I'm wanting to go all over the place. There you go. More fun with variant types. Here's a status type that I wrote up when I was working on a terminal Twitter client until Twitter basically told me not to bother. The neat thing about this is that if I get, so I've got my 3 standard HTTP status codes. If I get a bad request, I wanted to return some kind of status information with that, like it's good. Otherwise, I wanted to just have some wrapper so I could give you the status code and then whatever value is given in. The neat thing is that if I decide to handle something like, oh, say, internal server error, I could put an internal server error type right in here, and anywhere in my code that I use HTTP statuses, I would have to, right off the bat, take care of that case, or my code wouldn't even compile, which means I'm not going to be surprised when I'm off in production and I get some value that I don't expect as my HTTP status. There's an example of if you want to have a reference or just the straight value itself, you can wrap it that way. It's a horrible name, but they're good. Here's a lazy thumb for those of you into that kind of thing. You can just have a result, or you have a factory which produces a result of that same type. Here's that unit type we were talking about before. This basically says, I don't take anything, but I don't want to be, I don't want to take anything, but I don't want to be or I don't want to be fully closed. Okay, not mathematics speak. I don't take anything, but I still want to be forced to execute at a later point. So that's all weird functional stuff. The good news is OCaml also has imperative and object-oriented accents and training wheels that you can use until you get comfortable with all that weird functional stuff. It does have the imperative loops like for and while, but you don't really want to use them. You want to be using recursion in those cases, just trust me. If you do want to learn more about them, you can see section 1.5 of the OCaml manual. I'm not going to waste my time. OCaml also has objects, and objects are structurally typed, which basically means they're duck type. And if you care about the difference, I would suggest that you go check out 7 useful things you didn't know static typing could do, an introduction for the dynamic language enthusiast, out on my blog, where there's some guy who decides that it's very important that I admit that structural typing is inferior to duck typing. And we have about 60 comments on it. You could go and read that debate and start it up again and whatever. But basically, when I say it's structural typing, think you've got your duck typing for objects. Don't worry about it. The thing about objects is that the functionality is kind of redundant with the other stuff that exists in the language. And so if you're seeing a lot of objects kicking around, you're probably looking at code written by someone new to OCaml. Either that or they're more advanced at OCaml and I just don't realize it. One of the two. So with all of that talk about abstract stuff and what can and can't be done, at this point I figured I would launch into actual real code, interesting stuff, because if I go off into the abstract parts of it. I'm going to wander off into mathematics like you all will be bored. So here we go.
I'm just going to fix this one.
That's not how bad.
It's a little lower now. AV guy.
Ruby.MN AV club. Okay. So first, let's take a look at a pipe into operator. This operator is going to make it easier to express whole pipelines of things. Regenwald, in particular, really likes his code to read like it does. So he likes to say, well, take this thing and then do this with it, and then do this with it, and then do this with it. So in OCaml, we can do that too. Normally, function application style would kind of turn that upside down, and you would end up having to read from the inside out. So let's clean it up. That's the extent of it. I say, defining this weird named function, pump pipe right, which takes something and something else, and it applies that second argument, or takes the first argument and pumps it into the second argument. So here's a type. It looks a whole lot like our function application example earlier, except I've got what I'm applying coming first. In practical purposes, this will look like this. Take 2, pipe it into string of int, and then use the concatenator operator and say I had a, and that will give you I had a 2. You can thank Hamlet Darcy for that thrilling example. So handle handling. I've got some resource which is going to have global init and an instance init and an instance cleanup and a global cleanup, and it's going to exist for the whole scope of my program. So what I can do is I can define, well, here's my handle, and I'm going to just go global init, and then in the instance init, and I'm going to tell OCaml, well, at exit, execute this function, clean up the instance, then call the global cleanup, and then return H. At this point, you all should be getting up in arms and be going, what the hell? Because I told you there weren't imperative features, but here's that semicolon. And really what I'm saying is execute global init, then do this declaration, execute this thing, and then do that. Well, I'm cheating, because semicolon is actually an operator. It is actually an infix operator, which does whatever's on the left, throws out the result, and then does whatever's on the right. It's not exactly imperative, but it allows you to write a little bit of imperative code if you feel like that's the way to do it. Let's see, anything else particularly interesting in this? I don't think so. All right, ranges. Something like 5.10 or 10.5. Okay? Well, this is kind of an interesting case because we could either count up or we could count down. Okay? That's what the code looks like. So I'm going to create this operator. It's going to be called dash right because I couldn't come up with a better name for it. Now what this is going to do is this is actually going to build the list backwards. And the reason it's going, so if you do 5 to 10, I'm going to start with 10, and then I'm going to append 9, and then I'm going to append 8, and then I'm going to prepend 9, prepend 8, prepend 7, prepend 6, prepend 5. The reason I'm going to do that is because prepending is very, very fast in OCaml, while appending is very, very slow. So, so I'm declaring 2 things here, and I say, well, if the first argument's less than the second argument, that's like that case, then I'm going to grab this function called pred, which gives me the predecessor of some integer, and I'm going to grab this function called less than, which is kicking around. Otherwise, and that would be this case, I'm going to grab this function called successor and this function called greater than. And then I define this little loop where I say, if whatever that test is on my first argument and a, which is my starting value, Then I'm just going to return my accumulator because I'm done. So what I'm saying is, if my current value is, say in this case, and it's going to be less than this initial value, then we're done, time to return. Otherwise, we know we have to keep going, so we're going to get the next one, however that's done, predecessor, successor to pick. We're going to pass in a list, which is the first value, prepend it to the accumulator. That's it, that's our loop. And then here, we just say, we've defined the loop here. Here we're calling the loop with our first initial values being B and the empty list. All right, shoot.
Prepend is faster because it's building up tuples.
Prepender is faster because it's a linked list.
It's a linked list. Okay.
And then you would only class.
Yes.
Right.
I would be remiss if I did not do some kind of mathematical example. I think they would take my functional programming license away. Yeah. However, McLean said that if I did Fibonacci sequence, he would hurt me. So, here's the way to calculate a list of primes.
I passed out 20 minutes.
Damn, I would have been safe. That is a ton of code, but it's really not all as scary as it looks. I swear. First of all, we can just ignore this case. All we're doing is checking that the value you pass in isn't a negative n. You'll note OCaml does have exceptions. Fail with is a nice function that throws an exception. There are others. And then what we're going to do is we're going to say, okay, let's take a look at that n you passed in now that we know that it's not negative. If it's 0, I return you the empty list. If it's 1, I return you the list consisting of 1. If it's 2, I return you the list consisting of 1, 2. Life is good. Otherwise, I'm going to define this big function. Ignore it for a second. And I'm going to take 1, 2, prepend it to the front of the result of that big function when I pass in 3 and the empty list. Okay. So basically, this big loop is just going to build up my list starting at 3 and moving forward. The reason I'm starting at 3 is because if I start at 3, I only have to test every other one because, well, all primes are odd once you get past 2. So what I'm doing here is I see if the list is, I check to see if basically we've finished the list. Remember, we start with 2 elements, so that's their n minus 2. If the list is big enough, then I just reverse what I've got, and I pass it out. This list.reverse as a final thing is, again, a standard OCamlism because prepending is a lot faster than appending. Now I'm going to declare, so once that check is done, I know if I hit this point, I actually have to keep doing stuff. So I'm going to declare this function, which takes the mod of my argument that's passed in. So this is a little confusing because you're used to seeing x mod something, but this is still just the first argument to x, and so what I'm basically doing is allowing me to plug in later values, the second arguments to mod all the time. To check that it's prime, I just go through my whole list and I make sure that that mod function never returns 0. So at that point, I've checked all the primes underneath my n. I say, okay, for my next stunt, I'm going to call the builder again, with x plus 2. So that's going to be my next guess. If it's prime, I prepend the value. If it's not prime, I don't prepend the value and move on. So that's the example. Looks a lot scarier up on the big screen than it did on my computer. But finally, my favorite example of OCaml being is hijacking Rails date DSL API thing. That's that thing. 5 days ago, goes to some useful date function. So if we've got these things kicking around, let's start by defining the useful types which capture what these values might be. And then once we've defined that and worked it through, we're going to end up with a statement like, let x be the date 5 days ago, let y be the date 2 weeks hence. Pretty easy to read, all things considered. So here are our types. You got a scale, which is either hours, days, or weeks. Direction, which is either a go or hence. Straightforward. Again, if I decide to push out the scale, I'll know that all the code downstream will be able to handle it, because otherwise the compiler won't let it compile. This is the function. I define the number of seconds in an hour just because I feel like it. Then I'm going to say, well, if it's hours, this scale variable, if it's hours, I'm going to return that seconds per hours. If it's days, it's a second in a day. If it's weeks, that scale is going to be the seconds in a week. And then I match the amount, or then I set the amount to, well, if it's a go, that means I'm moving backwards. If it's hence, that means I'm moving forwards. Then I get the time of the day, I add the amount to it, and I pump that into a local time function, which gives me your standard time structure. So after all that, actually not too bad code at all, that'll give you your your stuff that looks like that. Date 5 days ago, date 2 weeks hence. You could define it as an operator or whatever else if you really felt excited to do that. But. So final example, and to kind of test your mettle, this is Perl's spaceship operator. The spaceship operator iterates over a file name and gives you each line in there. And then where it's normally used is in a while loop, and inside the block then, you'll define the way that you want to kind of mangle each line. Well, in this case, you're going to pass a file name, do that little at thing that looks vaguely like a spaceship and kind of like an artichoke. And then you're going to pass the handler, which is the function to do with each line. Open the channel. I'm going to close the channel down here. I take in the value. If I hit the end of the file, then I'm going to return none instead of sum, instead of the sum line. That gives me my line. If I've got some line, then I apply the handler to the line and append it to my accumulator. Otherwise, I don't do anything. If it's the end of the file, then I'm just going to reverse the things that I've got, because that's what we do in OCaml, and that's it. Pretty straightforward. And this illustrates, I think, an important part of OCaml, which is that OCaml does not come with a whole lot of bells and whistles right off the bat. OCaml is not, does not have operators to do everything you're going to want to do. Instead, OCaml gives you the tools and the capabilities to build those operators that you're going to want to use, or to import libraries which actually have them. Now there are some things in OCaml that I just don't get yet, and I'm still working on it. The first is monads. Monads are these really useful concepts where basically it's an inversion of control, except in the type system with all kinds of weird type guarantees. And they're really cool, and I like them a lot, except for the fact that I can never get to a point where I'm like, oh, this is where I should use a monad. So I'm still working on that. I also don't get this thing called phantom types. Phantom types allow you to literally put compile time tags on variables moving through your system, so that you can do things like guarantee that a write method or write function is never called on a database handle, which is supposed to be read-only. This is really incredibly cool, and I wish I could figure it out and get it to work, but it's kind of tricky in the whole type system structure. And usually, actually, I find that variant types themselves take care of the case, a lot of these cases. But there's some links, this will be up on the web, so there are some links you can check out to find out more about those two things. So where's OCaml heading? OCaml is heading in terms of multiprocessing. This is parallel computing, concurrent computing, all that kind of stuff. There are some people in France who will be very mad for me to suggest that this is the direction it's heading, but there's also a bunch of business which says that this is the direction it's heading, whether those people in France care. The JOCaml is the join calculus combined with OCaml, which basically gives you a way to refer to processes elsewhere, distribute your programming kind of along the lines of Erlang. There's a parallel garbage collector, which is being built right now, hopefully, I really hope, as a summer project sponsored by a wonderful company called Jane Street Financial. And so soon OCaml should, I hope, have a parallel garbage collector, which means that it's got no reason not to have intra-process threads. Right now, there are threads, but every thread, only one thread at a time is ever executed, which is kind of a bummer. And then there's this weird thing called Cloud Proxy being worked on by some idiot named Robert Fisher, which is intended to be a reverse proxy to work in something like Amazon's Elastic Cloud Computer, which will basically allow you to fire up and say, okay, whatever that is running over there, I want to proxy it. Or I want to be I want to replicate it. I want to do the same thing it's doing. There's this thing called transduce, that X is transduce, which is XML meets OCaml. You thought XML parsing in Ruby was nice? I hope not. But OCaml has a whole language kicking around, which is just built on top of XML. XML work. There's things like Factothorpe, otherwise known as F#. RoCaml, which is the Ruby OCaml extension, or OCaml Java, which is a port of OCaml onto the Java, onto the JVM. OCaml is trying to reach out into other runtime environments, work with other libraries, that kind of stuff. Just generally kind of ping other communities and let them know that we exist. And then you have these things like Oxygen, Laconic Web, and XNum. I have no idea if that's actually how it's pronounced, but it's done by a bunch of people who apparently only speak Italian, so I'm not all that concerned about them hearing it. These are efforts to port static type structures like exist in OCaml into the web app sphere. Oxygen is the most mature of all of them, and it's kind of cool, and I kind of like it, but I haven't quite gotten my head around it because I haven't had the free time. Laconic Web doesn't really exist yet. It's in 0.001 alpha. And XNUNC claims that it runs, except it has no documentation, so I haven't actually been able to figure out, well, no documentation in English. It's all in Italian. So if you speak Italian, go check out the XNUNC project and let me know how it goes. And mostly I'm doing this presentation, well, because I was asked to, but also OCaml really, really, really needs you. By you, I mean Ruby developers. And there are a bunch of reasons for this. First, Ruby really likes to do documentation because you guys kind of have to. And you guys really like intuitive, natural tools. OCaml, mostly C programmers. Not so intuitive, not so natural. It would be really nice to get other people in that community really pushing for ease of use on the tools. Ruby has a structure called pragmatic development, unit tests, things being, that kind of stuff being important, maintainability. There's a kind of hubris that comes with the power of OCaml, where people start to think, well, if it compiles, it must run right. This is not true, but it does mean that, well, yeah, this is not true, but this does lead a lot of people to not really worry about writing a lot of unit tests or that kind of stuff. And I'd like to get that changed in the culture. OCaml people, OCaml runs at C++ level speeds. They're really excited about that. So you get a lot of people who are speed demons, who are asking, man, how can I just get away from allocating this tuple because it's like using 17 clock cycles. And as Ruby developers, you're obviously not all that concerned about performance. And it would be really nice to bring some of that attitude in here too. Mostly though, OCaml just needs more people. OCaml has a community which is passionate but small. And it needs more people to come in, work on more open source libraries, contribute more work, and generally beat on the language so that we can figure out which direction we should really be heading in as we move forward. A bunch of information out on the web for OCaml. People always bitch about there not being a good OCaml book in English, but the documentation online is so good in English that I've never really cared. There's this site called Godi, that's OCaml's gem. If you want to install OCaml, that's the place you go. The OCaml's manuals is a pretty good introduction, better than what that's been going through here, but also a lot more involved. There's an OCaml channel on Freenode, which is populated with a lot of interesting characters and is generally a pretty good place to go and ask for questions. There's an OCaml beginner site on Yahoo, which was started because there were a lot of people asking a lot of extremely simple questions on the main OCaml mailing list, which, if you subscribe to the main OCaml mailing list, you're going to get bombarded with a fair number of pretty deep type questions. So if you're going for a PhD in computer science, that's a great place to follow. There's other places to go to, like the OCaml Forge, which is the source forge for OCaml, the Caml Hump, which provides updates on update on open source project statuses, and then the wonderful company called Jane Street. They've got a great blog which goes through and deals with some of the intricacies of actually coding OCaml in a practical way. I didn't know Brian Hurt was going to be here, but I felt he needed to be represented, so I put this great quote from Brian Hurt on there. And if you have any other, if you're curious to learn more, I suggest just wander over to my blog, punch in OCaml in the search term, and see what else is going on. And that's all I got. So at this point, I'm going to open it up to questions and hopefully answer most of them.